So we need to determine the coordinates of the vertex and the focus, equation of the axis and directrix, and the length of the lattice rectum of the parabola y squared equals to 5x minus 4y minus 9. Let's begin. Now we'll start with the given equation of the parabola. What we'll do, we'll take y squared and we're going to transpose negative 4y from the right hand side to the left hand side to get positive 4y. So that will be equals to 5x minus 9. The reason why we transpose 4y from the right hand side to the left hand side, because we are going to convert the two terms y squared plus 4y into a perfect square by completing the square. So here we will get y squared plus 4y plus 4. Now 4 is an extra term that we are adding, so we need to subtract it. Well, we can also do is add 4 to the right hand side. Now y squared plus 4y plus 4, that's y plus 2 whole squared. We have successfully converted into a perfect square. And then we have 5x, so negative 9 plus 4, that's going to be negative 5. So here what we can do, we can take 5 as the common factor on the right hand side. So 5 gets multiplied to x minus 1. So this is the equation of the parabola in standard form, but the vertex of the parabola has been shifted. To find out the vertex of the new parabola, what we'll do, we're going to make a substitution here. We're going to consider x minus 1 to be equivalent to x in uppercase and y plus 2 to be equivalent to y in uppercase as well. That means equation 1 now transforms to y squared equals to 5x. As you can see, this is comparable to the standard form y squared equals to 4ax, which means that the value of 4a, that will be equivalent to 5, and that gives us the value of a as 5 over 4. Now let's try to understand the graph of y squared equals to 4ax. So here we have the graph of the parabola y squared equals to 4ax. Now the reason why we converted our given equation of the parabola into the standard form, because for this particular standard form of the parabola, the vertex is always going to be at the origin. Then we have the focus at the point a comma 0, and we have the axis on which the vertex and the focus line, which is defined as the axis of symmetry of the parabola. And in this case, the axis of symmetry line is lying on the x-axis, so its equation is given by y equals to 0. Then on the axis of symmetry line, we consider another point with the coordinates negative a comma 0, and through this point we are going to pass a line which is perpendicular to the axis of symmetry line, and this line is referred to as the directrix line. Then the equation of the line is going to be x equals to negative a, since it is parallel to the y-axis. And then we have the another straight line which is passing through the focus of the parabola, and it is perpendicular to the axis of symmetry line with its endpoints on the parabola. So this line is referred to as the lattice rectum, and its length is defined as the absolute value of 4 times a. Now from our problem, we have already found out the value of a. A is 5 over 4, and we use the substitution x in uppercase with x minus 1 and y in uppercase with y plus 2. So that means this figure of the parabola, here we are working with the new coordinate system, that is with respect to x comma y. And then what will our goal will be to use these two substitutions to transform it back to the original coordinate system or the old coordinate system. Okay, so let's start with the vertex v. So here the vertex of the parabola is at the origin. This value simply tells us that the x value is 0 and the y value is 0. In order to get back to the old coordinate system, we're going to replace this x value with x minus 1, such that x minus 1 will be 0, and in place of this y, we're going to replace with y plus 2. The y plus 2 equals to 0, so solving for x and y, we get x equals to 1 and y equals to negative 2. This means that the coordinates of the vertex of the parabola will be at 1 comma negative 2. Now we'll come back to the focus. So we considered the focus according to the new coordinate system at a comma 0. Since a is 5 over 4, we have 5 over 4 comma 0, that's going to be the coordinates of the focus, which means x corresponds to 5 over 4 and y corresponds to 0. So we are going to go back to the original coordinate system. So here we have x equals to 5 over 4 in the new system. In the old system, it will be simply x minus 1 equals to 5 over 4. That's going to give us x equals to 9 over 4. And then we have y equals to 0. So here we'll get y plus 2 equals to 0, which means that y will be equals to negative 2. So that means the coordinate of the focus is going to be 9 over 4 comma negative 2. Fine. So we have the coordinates of the focus in the old coordinate system. Now coming to the axis of symmetry. So in the new coordinate system, that's y equals to 0. So in the old coordinate system, we're going to replace this y value with y plus 2. We get y plus 2 equals to 0, which gives us y equals to -2. So that's going to be the equation of the axis of symmetry. Now coming back to the directrix, the directrix is given by x equals to -a. That means we have x equals to -a means -5/4. So what we'll do, we'll go back to the old coordinate system, replacing this x value with x minus 1. So x minus 1 will be equals to -5/4, which gives us x equals to -1/4. So this is going to be the equation of the directrix. And then finally, we want to find out the length of the lattice rectum. The length of the lattice rectum, which is given by absolute value of 4 times a. So replacing a with 5/4, so we're going to get the value 5 units. Now, regardless of which coordinate system we use, whether we use the old or the new one, the length of the lattice rectum is always going to stay fixed at 5 units because the shape of the parabola remains unchanged when we do a coordinate transformation. So this is how we have successfully obtained the coordinates of the vertex of the parabola. That's at 1, -2. Coordinates of the focus is at 9/4, -2. The equation of the axis of symmetry line, that's y equals to -2. Equation of the directrix is x equals to -1/4. And then length of the lattice rectum will be 5 units.